1, 2, 3. Can everyone hear me?
I can hear you.
Okay, great. Okay, hello everyone again, and welcome to my talk about Docker and Perl. What are we going to talk about today? I'm going to try to explain what Docker is. We're going to take a look what is our main motivation from the point of a developer and from a point of a system admin. I'll try to show you how to build a container. And anytime you have questions, just feel free to interrupt me, let me know, and afterwards I'm not sure if there's going to be time. Okay, my name is Denis Banovic. I work in Salzburg for a company named NCM. We love developers. We build tourism applications for tourism Austria in Austria. And we love developers. That's why we send them to OSCON, YAPSIs, German Perl workshops, and so on. And when I'm not doing Perl, I'm doing this.
Come on, man.
Okay, Docker. What is Docker? First of all, think of Docker like a VM, virtual machine, but only for single process or for applications. So basically, instead of running the whole virtual machine in running the whole OS layer you have, here you're basically just running a small, lightweight layer that will abstract your application runtime. So think of it as a standardized way to ship and run your application. And by standard, I mean really a great standard, because a lot of the big companies started from Red Hat, IBM, and so on, jumped on this and are working all together to improve the Docker experience. Docker reached 1.0 like 2 months ago. Right now it's at 1.1. I personally wouldn't run it in production yet, but there are a lot of people out there running it in production, and they're happy with it. So, like I said, it's a standardized way to run your application, and a really big point here is that if it runs on your test machine, it will also run on your production, it will run on your stage. You don't have these module dependencies, environment dependencies, and so on. So it's great for that. And what's also great for is when you have this service-oriented thinking. Like when you think of big applications that gets more and more complicated, and all the functionality is built into the application itself, it gets harder and harder to maintain the application. Because when you change something here, it breaks something over there. And with Docker, the concept of having services for every part of your application, or microservices even, Docker makes it really easy to do that. Hi, guys. So let's see motivation. Why do we want to do this? So first of all, I'm a developer, and usually when you host your application somewhere, you depend on the environment that is out there. And with Docker, you're not. You just choose your own language. You choose your modules you want to have. You choose the versions you have, and you can have many of those on one production server running, because it's all encapsulated, just like you can have many virtual machines running that are independent. Like it's basically your application is running in the sandbox. Deployment is really easy. It's one file that you push to outside, and it runs. And like I said, it runs everywhere. As long as you have Docker installed on that machine, it runs. From the sysadmin or from the ops point of view, they also have the same benefits, because if it runs on developers' notebook or on test server, it's going to run on stage and production. When the sysadmins push out the code, they don't have to worry about dependencies and stuff like that. Easy deployment, easy scaling. Easy scaling means you can basically run one instance of the container, or you can spin up 5 or 10 or how much you want. And here also great for sysadmins is when a developer installs, I don't know, Redis, MySQL, and so on, he's not really a sysadmin most of the time, so he will just set it up quickly and make it work. Sometimes that's not good in production, and here sysadmin can create templates. So when a developer creates an image, he will just use the template for the MySQL database or template for the Redis, and it's all already set up, and these templates can be provided by sysadmin. So it's kind of trying to make it easy for them to do it right, but make it hard for them to do it wrong. So it's a great benefit. So getting started, step by step, what do we need to build a container? First of all, you need a Docker daemon running on the host where you are. Then you don't want to start from scratch. That's why there are a lot of Bootstrap containers out there available. Docker has a kind of a GitHub for containers. So you should just go and download one that suits you best. It can be a completely empty operating system, or it could be a Perl container. There are official containers out there available. So you just go and say, OK, use Perl, and you can run your application. Then you just throw in your application into the container, and you're done. So to do this, here's a typical Docker file. So I want to explain this a little bit. Docker file is, you can think of it as a Puppet script or Chef or similar. So it basically defines how your container should be built. So guys, anytime questions, just interrupt me, okay? So what I'm saying here, use the Perl image, the official Perl image from hub.docker.com, something like that. And when he's building your container, he will first go and fetch that Perl image and start based on this. Then the second line is basically, who's responsible for this. Then in the third line, the command add will mount the Mojo directory into /Mojo. So this is basically put my application inside. Then I want Modulicious to be installed there. So I run Modulicious install script. Then we want to be able to access this container from outside. So we will expose the port 3000 to the live world. This doesn't mean that it's accessible yet when you build it, but this means that this port is available to be accessed. I'll explain that later. And just for testing, I've added the environment variable Docker. So that's the standard Docker file. And of course, these get complicated when you have more stuff to install and so on. But that's about it. Then this is how you build your image. You just go into that directory where you have the Docker file, say Docker build, and this is usually what happens. So step one, he will download this Perl image, add the mojo, and install the Modulicious. That's about it. And this is our image. This is the ID of our image that we can then use to run the container. So, and the next thing is we want to run it, right? So we created the image. So what you have to think when you say Docker run, it will create an instance of that image. And every time you create when you say run, it will do a next one and a next one. So you basically want to say this only once, and afterwards you want to say Docker stop and Docker start.
This is hitting the microphone and it's creating some noise.
Okay. Sorry.
Okay, can you say something?
Say something? Okay, that's our simple application. We have that running. That's it. Just a few commands I want to show you before we go to the live demo. So the first one, Docker PS, will display what's the last with L will display the last image or the last container that it's running. Like I said, Docker start, and you don't have to use the full ID. You can use if it finds the unique from the first few letters, you're perfectly fine. And Docker start IA will attach you to the standard input and output of the container, so you can take a look inside and see what's happening. So what I did here for the presentation, I've downloaded the latest CentOS 7. We have Docker 1.0 running on it, and it's Modulicious. So let's take a look. So, okay. So first of all, I want to show you Docker PS. Right now I have this one. Oh, can everyone see that? It's a little bit darker. Let me change. Okay. Better?
Can you move up the bottom half of the screen more?
Here? Yeah. Okay. So, Docker PS, we have the container ID. This is the command that I executed, and the ports here. I said put the port 3000 and run it on 3000, so we can access it from our system. So let me get back to this. So, okay, here you are. So reload. Yeah, it still works. Okay. I had problems with my virtual machine, but it works. So I have a second thing in there. This is environment. Okay, so this is if I just dump the environment variable, this is how it runs. So and now let's try to change this. So right now I will create a new container based on the image that we have. I've just changed the stat.pl, so it should then say hello Sophia. And as soon as you save this, we can then do okay. So what I'm going to do now is okay, I will pull this a little bit up so everyone can see what I'm doing. Okay. So the Docker build what's happening right now, he will build my container, add in the mojo, and it's posing 3000. Okay. Okay. Fingers crossed. Yeah. So right now we have a new container. This is the ID of the new container. Yeah, thank you. So let's run this container. So this is the ID that I'm editing. So, oh, okay, sorry. First we need to stop the other one. So docker stop EE should be enough. Yes. So, and this was E6. So E6. So, any variety? Yes, perfect. So when I reload here, it should say hello, Sophia. Yes. Okay. That was the live demo.
It works. The live demo works.
Yes. I had to fake downloading the modulicious because I didn't want to. Didn't want to rely on the Wi-Fi. I learned from my mistakes. So yeah. So we are ready to take questions if anyone has questions. Yeah, sure.
You said it runs a single process. Does that mean that you can have forked processes inside
Yeah,
the container?
you can run. It will. That's not a problem. Like 14 processes inside is not a problem. But the thing is, when you start the container, the command that you execute is a single one, and as long as this command runs, your container is running. As soon as this command stops, your container is exiting.
So what about, let's say, a web application that you normally run on a server with, 8 CPUs? How would you do that in Docker? Would you have 8 Docker instances running for that app?
Yeah, but you can give Docker. You can specify how much power you want to give to that Docker.
So I could have a Docker with multiple CPUs
Yes,
or processors.
that's not a problem.
Okay.
Yeah.
Which user is running your application inside the container?
As far as I know, it's the root.
Root?
But you can configure that also. Per default, it's the root.
Is there a way to access the container file system from the outside? For example, when your application generates logs and so on to
Yes, there is. You can install like in Docker. You can create shared directories that will be not written in the container itself, but like on a shared directory of the host. So you can put your logs in there. But there are also a lot of different solutions for logs, so you just go out and choose one that suits you the best.
You mentioned that there is a repository of the initial images.
Yes.
This is publicly updatable.
Yes.
Is it a bit risky to rely on an image that someone else put there?
Yes, that's why you should always use the official. If you need to do something like security responsible, so you should take the official images. These are proven by Docker company itself. They build them by self, and you can find everything there from Perl to I don't know, CentOS images and so on. So. Yeah, but later, when you create your own images, you can push them outside. So your sysadmin can install MySQL as you need it, configure it, push it outside, and then your developers can take just take this and you can have private repository and a public one. Yeah. Oops, sorry. More questions? Yeah.
With this kind of setup, like when, let's say like you deploy a bunch of images with MySQL and there's a security issue in MySQL, you have to go back and rebuild each and every image, right, to get that update into it.
Yeah.
So there's no way to do like centralized updates with
they like the community behind Docker is huge right now, and it's growing exponentially. So every problem you think of from the sysadmin point of view, I'm sure they will be solving soon, because like a year ago, Docker was basically unknown. Yeah, only people who knew .cloud heard about Docker. Yeah, and right now they had a conference in San Francisco where they had like over 600 people and 600 more on the waiting list. It's just exploded, this thing. Yeah. And the case that Red Hat actually brought it into the CentOS 7. You know, usually it takes like 5 years to get something into the Red Hat enterprise, yeah. And they just brought it in under a year in there, yeah.
Okay, I don't think we have any more time for questions. Thank you very much.
Thank you.